In California, building ventilation requirements are governed by the Building Energy Efficiency Standards, specifically Section 120.1, which outlines the criteria for ventilation and indoor air quality. These standards dictate the necessary ventilation rates based on two key calculations. First, a minimum ventilation rate is determined based on the floor area of the space. This calculation ensures effective removal of pollutants associated with the building itself. Second, a minimum ventilation rate is calculated based on the maximum number of occupants the space is designed for. This ensures effective removal of pollutants generated by the occupants. Then, the larger of these two calculated values is set as the minimum ventilation rate. To calculate ventilation requirements based on floor area, you multiply the area of the space in square feet by the area outdoor air rate, RA. This rate depends on the type of occupancy and can be found in Table 120.1-A of the California Building Energy Efficiency Standards. For example, the table shows 0.38 CFM of ventilation per square foot is required for classrooms with children ages 9 to 18. Let's consider a sixth grade classroom spanning 1,000 square feet. To determine the minimum ventilation rate for the floor area, multiply 1,000 square feet by 0.38 cubic feet per minute per square foot. This yields a minimum ventilation rate of 380 CFM, based on floor area. The term CFM refers to cubic feet per minute of outdoor air delivered to the space. The occupancy calculation involves multiplying the number of people that can occupy the space by 15 cubic feet per minute per person. Consider our example of the 1,000 square foot classroom. Let's say it's designed for 30 people. To find the minimum ventilation rate based on occupancy, multiply 30 people by 15 CFM per person, resulting in a minimum ventilation rate of 450 CFM. Remember, the minimum ventilation rate is determined by the larger of the floor area rate, 380, and the occupancy rate, 450. So in this case, the minimum ventilation rate is set at 450 CFM. The minimum ventilation rate is required whenever the building is occupied, unless advanced controls are implemented, which we'll discuss shortly. Keep in mind that this minimum ventilation rate calculation method is specific to California. In most states, standards from the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRAE, known as Standards 62.1 and 62.2, are followed. While the calculation process in ASHRAE standards may differ slightly, the outcomes are typically comparable. In general, larger spaces, specific types of environments, and areas with higher population densities require more ventilation. Before we move on, let's discuss one other common calculation. Sometimes ventilation rates are converted to a metric called air changes per hour, or ACH. To determine the outdoor ACH for a room, we apply this equation. Start with the ventilation rate in cubic feet per minute, divide by the volume of the room in cubic feet, and multiply by 60 minutes per hour. This metric tells us how many times per hour the entire volume of air in a room is replaced with outdoor air. Let's return one more time to our classroom example where the ventilation rate was 450 cubic feet per minute and the floor area was 1,000 square feet. If the ceiling height is 10 feet, the volume is 10,000 cubic feet, and the ACH is 2.7. This means that the indoor air is replaced by the outdoor air 2.7 times per hour. A higher ACH indicates more effective removal of indoor pollutants. Typically, outdoor ACH rates range from about 1 to 4 in commercial buildings, while in homes they are generally less than 1.